Life. Something incredibly simple, yet the more you think about it, the more complex it can get. Bill Bryson's A Short History of Nearly Everything tells the story of life, and especially the beginning of the life of our universe. The life of our universe started with nothing less than the Big Bang. Our story begins before time or space existed. All there was a single singularity, a single point with no dimensions, into which 98% of all the matter in the entire universe was crammed. Whether a part of a continuous cycle of collapse and expansion, or just one universe in a group of many, we may never know. But at some unknown point around 15 billion years ago, for some unknown reason, all of a sudden there was a massive expansion in this matter. Traveling outwards in all directions, it began to create our universe as it went. In less than a second, the forces that govern our world, like gravity, had been created. In less than a minute, the universe is now 1,000,000 billion miles across, and has begun to create the light elements, like hydrogen, helium, and lithium. This theory, perfected over time by many different scientists, became known as inflationary theory. The idea that the universe began rapidly expanding a fraction of its time after the Big Bang. Forces in elementary particles, created in incomprehensibly small amounts of time apart from each other, began to shape the universe in which we live, and allowed for the fusion reactions of stars to begin to take place. Now let's take a step back and look at our own solar system. Though somewhat of an oddity, being a one-star system, it is still the home we have. Even to travel just to the edge of our solar system, to the Oort cloud, it would take us 10,000 years traveling in the fastest human-made spaceships. Space is, unfortunately, enormous to staggering degrees, beyond our comprehension. Even our own solar system, if properly scaled, would leave Earth the size of a pea and Pluto over half a mile away from Jupiter. Space is called space for a reason. But theoretically, what if you were to try to make it beyond our solar system and to the edge of the universe and see what lies beyond? Well, ignoring the fact that it would be impossible for you to survive your travel, you would be disappointed to find that there is no edge to our universe. It is curved, allowing it to be boundless, but also finite. If you travel in a straight line out, you would never reach an end, but rather come back to where you started. This same thing means that there is no center to our universe. There is no direct place where we can pinpoint where the Big Bang happened. Now, one question that remains to be answered is where do we find the rest of the matter in our universe? And especially the essential heavy elements like carbon, iron, and many others that we use to make up our own bodies and our planets. Ironically, the birth of these essential life elements lies in the death of another thing. When a massive star dies, 10 or 20 times the size of our own sun, it can explode into what is called a supernova. This gigantic explosion of a dying star creates hundreds of millions of degrees of heat, the amount necessary to create the heavier elements. Then, these new created elements would be flung across the universe by the explosion. This violent explosion, while destroying everything close to it, also provides us with the building blocks for the rest of the universe and our very own human bodies. Eventually, these large quantities of matter began to come together and form solar systems and the things inside them. The sun, the heart of our solar system, took up 99.9% of the matter in our solar system. Out of the material left floating around, small particles and grains of dust began to collide, forming larger and larger clumps. As they continued to expand, they collided with even more bits of matter, slowly growing from indistinct bits of space dust into planetesimals, and eventually into planets. This all happened in around 200 million years, though the Earth was far from being inhabitable at this point. At some point around 4.5 billion years ago, a huge body of mass, about as big as Mars, collided with the Earth, and enough material from the Earth broke off in the collision to form the Moon. As both of these bodies solidified, the Earth also began to accumulate greenhouse gases, like carbon dioxide, methane, sulfur, and nitrogen. Though not what we would consider essential for life today, these gases kept the solar radiation trapped in the developing atmosphere and allowed ice from crashing comets to begin to melt and life to begin in its first stages. Though we still have a long way to go until we get to us, the basics of our existence have been created, and the first bits of life have formed. Though seemingly violent and even random at times, the path to us could have happened no other way.